Hello, my name's John Perham, and in this short sequence of videos I'm going to examine the various meanings of equality as understood by mathematicians. So, using a computer algebra system such as Mathematica, which is this one, to relate a mathematical narrative requires a more disciplined use of symbols and terms than is common in mathematical text. For example, we distinguish three examples in the usage of equality: the process of naming a mathematical expression, the process of assigning a value to a variable in an expression, and the conditional assignment of equality between the two sides of an equation in order to solve it. We show that Mathematica has three different constructions for describing these relationships and explain why we believe that fully integrating a computer algebra system into mathematics education for science and engineers should provide a better understanding of these concepts than the traditional narrative in terms of mathematical text. So, anyway, this talk is based on an article I've written of the same name, which is to be published in the magazine Parabola, produced by the Mathematics Department at the University of New South Wales, and here's a link to its webpage. So let's get going. So this article is based on my 15 years experience in attempting to enhance mathematical learning using computer algebra systems, and more recently my experience here at the University of New South Wales as a sessional first-year tutor. A significant proportion of the test scripts handed in consist of a collection of mathematical expressions or statements of the form left-hand side expression equals right-hand side expression, without any comments as to what is meant, why it is useful, or how it contributes to the solution of the problem. The process is complicated because the failure to carry out simple transformations correctly leads to statements of the form left-hand side expression is not equal to right-hand side expression, and this usually makes further progress impossible. Well, I believe that part of this basic lack of understanding of the processes involved in solving a mathematical problem is that such statements can occur in three contexts. The first context, or at least three contexts. The first context is illustrated as mathematical text by stating something like, let the function f of x be defined by, and here's this expression here. And what this actually does is establishes an identity between the two patterns of symbols on either side of the equality sign, so that for this problem the symbol f of x is actually the name of the expression on the right. The second context occurs when we wish to visualize f of x, for example, as a graph for some numerical value of the parameter b, because we can't draw a graph of this until we specify a number here, for which the context is something like, for the purpose of plotting f of x, it is necessary to assign a numerical value to the parameter so that we set b equals 1. So we've used the equality sign again, but in a completely different way to this, because in this context we are certainly not associating the name b with the integer 1, but instead providing an instantiation of the function f of x. The third context occurs in the solution of equations, an example of which is x squared plus bx plus 1 equals 0. The meaning of the equality sign in this context is, if the expression on the left is equal to the value on the right, find the values of x for which this is so. As we can see, normal mathematical text uses the same symbol for all three contexts. As we shall see, the computer algebra system Mathematica uses different syntaxes for the three distinct contexts. So in the remainder of this article, I begin with a discussion of the relation between using a computer algebra system for solving mathematical problems and the process of programming a computer. I then present a discussion of the algebraic geometry of ellipses to illustrate how Mathematica deals with these three contexts of equality. And finally, I present a solution to the problem of drawing tangents to the ellipse, showing how mathematical tools in the form of code fragments developing in solving one problem can be reused to solve another. So let's pause here.